Hello again. Let's look at some more examples. Let's say we've got 36x to the 2/3 over 4x to the 4/7. Now what you do is you divide 36 by 4 and you get 9. Now by the laws of exponents, you have x to the power of the top exponent minus the bottom exponent. And just to make this clearer to look at, let me create some space. So we have 2/3 minus 4/7. By the exponent rules, we subtract 4/7 from 2/3, like this. Okay, and now to do that, we get common denominator, recall from arithmetic, and then 14 minus 12 is 2, so you have 2 over that common 21. So we have 9x to the power of 2 over 21. And you can put this in radical form, but I won't bother doing that just yet. So there, I just want to do the exponent rules right now. So let's move on down. Now here 5 and 4, they won't reduce. So that's just 5/4. The 4 on the bottom, the 5 up top. And then you do 2/3 minus 4/7 and you get 2 over 21, just like you did before. And it would be nice, I know, the fontage here is not really that great. So let me create a little space between these minus signs so you can read it. That's all, just for readability. Everything here is correct, but I just want to create some readability, okay? So there's that. Just put a space between the minus sign and the fractions here and here. But anywho, now if you have like 10 over 4, down in this next example, 10 over 4 reduces to 5/2. It'd be 10/4, yeah, but that 10/4 reduces to 5/2. And so you have 5/2 x to the power, you do 2/3 minus 4/7. And then you just get common denominator again, and you wind up with 2 over 21 again. And again, it would have been nice if I'd had that space between, but it may get arduous or tedious to do this for every problem. But I'll do it for the time being anyway. So there's that. Now, oops. Okay, let's look at something else. Recall how to deal with negative exponents. Like x to the negative m equals 1 over x to the positive m. Like x to the negative 8, follow my cursor right here. X to the negative 8 is just 1 over x to the positive 8. And that's true of any x to any power, by the way. And like, now, the converse is true. If you have 1 over x to the negative 8, that's just x to the positive 8. For example, if you have 7x to the negative 1/6. Now, this is going to open up a can of worms a little bit, or a topic that's a little tricky. So we have 7 over x to the 1/6 power. Now, guys, what I do, this is correct. 7 over x to the 1/6 is correct, but to the confusion of many calculus students and algebra students, the answer you get in the back of the book will look different than your answer, and you'll think your answer is wrong when it's not really wrong at all. You just didn't put it in the form they wanted. The thing is, remember, x to the 1/6 power is a radical. It's the 6th root of x. It's the 6th root of x. So we don't like radicals in the bottom. So what I do is I ask myself the question, 1/6 plus what is equal to 1 itself? Well, to get 1 itself, it'd be nice if this 1/6 was 6/6. It's not, but it would be nice if it was. But I can sort of make that happen. What I do is I stick an x to the 5/6 on the bottom. And what's going to happen is, by the rules of exponents, I'm going to get x to the power of 1/6 plus 5/6. But that's just 6/6, which is 1. That's just x to the 1 down here. But now the price you got to pay is if you stick an x to the 5/6 down here, you got to stick 1 up here. What you multiply the bottom guy, or the bottom of a fraction by, you must also multiply the top of that fraction by, if you don't want the overall fraction to change, and we don't. So we multiply the bottom by x to the 5/6. We multiply the top by x to the 5/6. And what's going to happen is that 1/6 is going to add to 5/6 and give me 1. But let me just show you, just so I won't confuse you about the law. Here's what I meant by the law of exponents. You get 5/6 plus 1/6. By the law of exponents, this guy turns into this guy. Now, the numerator doesn't change any. We just leave it be. So there's that. Now remember, guys, 5, 6 plus 1, 6, you add the 1 and the 5 and you get 6, so it's 6, 6. But remember, 6, 6 is 1. It's just 6 divided by 6. So you just get x to the 1, which is x itself. So again, I'll write, yeah, sure, that is x to the 6, 6. But that's just 6, 6 is just 1. And x to the 1 power is x himself. Yeah, there's an understood 1 right here where this x is. And then the numerator, let me write it. It doesn't change any. So there's that. And my final result is 7x to the 5, 6 over x. And you're like, well, why did I introduce this? Because you may as well get used to it. You're going to see it a lot in math, and that's just the way it is. Okay, so that was a bit of a pain. Now for this one, let's go to the next problem. We actually get out of it on the next one. This x to the negative 1, 6 just comes up as x to the 1, 6, and we don't even have a denominator anymore. We don't have to worry about fixing things up. It's over. That's all this guy right here is. This guy is different than this guy. These are not the same problem, by the way. As you can tell, this is 7x to the 1, 6. This is 7x to the negative 1, 6. Okay. And again, now if you have 7 over 3x to the neg 1, 6, the x to the neg 1, 6 just jumps up as x to the 1, 6, and you get 7/3 with a 3 on the bottom. So nothing really changed there, except the x to the negative 1, 6, which came up as x to the positive 1, 6. But these are the same fraction. This is just a nicer format. We want to get this in a simplified format. And now if you have like 33 over 3 x to the negative 1, 6, well, yeah, true, you get 33/3 x to the 1, 6. But remember, 33/3 is just 11. So be sure to reduce and clean up all fractions as you need to, okay? And now let's look at this next one. 33x to the negative 1/12 over 3x to the negative 1, 6. Now watch out. Here's what happens. That x to the negative 1, 6 jumps up and becomes x to the positive 1, 6. That x to the negative 12 jumps down and becomes x to the positive 1/12. Now the 33 and the 3 don't change. You know, they weren't involved in the power process anyway. So you just get 33/3, and then by the law of exponents, you just get a single listing of x raised to the power of 1, 6 minus 1/12. Now, but remember, 33/3 is 11, and 1, 6 minus 1/12, I skipped the step, but you go through the common denominator process, and you'll end up with 1/12 when it's over. So you get 11x to the 1/12 when you do all this, okay? The 11's obvious. The 1/12, the trick is, you remember you turn 1, 6 into 2/12, and 2/12 minus 1/12 is, well, 1/12. And there's that, okay? And now let's look at this one. Now this time we're cubing everybody. So this times that parentheses cubed is this cubed times that cubed. We cube the 4, and we cube the y to the 1/5 power. So we get 4 cubed. And now remember, by the law of exponents, you multiply this 1/5 by 3. 1/5 times 3 is 3/5. So it's y to the 3/5. Now, 4 cubed is 64. And then we have the same old y to the 3/5. It's not going anywhere. So our final result, our final simplified result is 64y to the 3/5. Now let's look at this. If we have like 4y to the 1/5 entity cubed, the whole entity cubed, over y to the 1/5. Now, what you got to do is, yeah, I skipped way too many steps there. I'm correct, but I skipped too many steps to be pedagogical. Remember, you cube the 4, you get 64, and you multiply the exponent of y by 3, and you get y to the power of 3/5. And you have the same, for now, we have the same guy on the bottom. And then, so there's that. But remember, by the law, you know what? Let's just go ahead. This is correct, but that's 4 cubed. And let me just go ahead. Now remember, 4 cubed is 64. It's silly at this point. 4 cubed is correct, but let's just go ahead and call it what it is. It's 64. 64 was correct here, but I wanted to not skip that step. So 4 cubed, y to the 1/5 cubed, which is y to the 3/5. So we have 64 here. Now 4 cubed is 64. Now remember, by the other law of exponents, we do 3/5 minus 1/15. And that goes here. And then now, guys, when you do this, remember you got to get common denominator, which is 15. So you'll have 9/15 when you do times 3 times 3. So 9/15 minus 1/15 is 8/15. So there's that. So we have 64y to the 8/15. So there's that. Okay. And then if you stick a 2 down here, it's no biggie. There's several different points of view. You're just doing 64 divided by 2, which is 32. But anyway, so you get the same stuff, except you have this 1/2. That 1/2 comes on account of having 2 on the bottom. To divide by 2 is the same thing as to multiply by a half. So we have 1/2 times all this, and you're just going to get 32 instead of 64 when it's over, because that 64 is going to multiplicatively bump into that 1/2. Remember, to multiply by a half is like dividing by 2, so 64 divided by 2 is 32, okay? So there's that. Now, what if I spice it up and make it more interesting? I have the same guy up top, but this time I have a negative power. Instead of 2y to the 1/15th, I have 2y to the neg 1/15th. Well, I have the 1/2. That's just there for the same reasons it was up here. No biggie. 4 cubed and the y to the 3/5, they're going to be there. But now notice what I do is that y to the neg 1/15 jumps up and becomes y to the pos 1/15th. So I add. Another way of looking at it is we're minusing a negative 1/15th, which is plus 1/15th here where my cursor is. So if that bothers you, if you don't want me to skip any steps whatsoever, here's one way to look at it. Before we ever even cube the top, so to speak, let me write this out just real quick. I'll try not to do a long moment of silence or anything on you. You can go ahead and just hit a times sign just to be neat and petite about it. Yeah, that looks funky without a times sign. Hit a times sign and bring that y to the neg 1/15th up as y to the positive 1/15th. It was negative on the bottom. It jumps up as a positive on the top. Now that 2, you can't bring that 2 up. That 2 has to stay down there. Okay. Now so that since we're dividing by 2, that's going to act like a multiplier of 1/2. So 1/2 times 64 times y. Now this time, now you still got to do order of operations. You got to cube everything first before you can even budge. Let me insert the other step that I skipped. I did skip too many. When I'm typing this, everything feels good at the time. Then later I get quite humbled. But remember, you cube the 4, you cube the y to the 1/5, but that's just y to the 3/5. Okay. Well, of course, 4 cubed we know is 64, but anyway, there's that. And we're dividing the whole thing by 2. Oops, and don't forget your other guy, your y to the 1/15th. Aha, okay, so there's that guy. So we have, now we're liberating anybody upstairs. So it's 4 cubed, y to the 3/5, times that y to the positive 1/15th. Guys, we like, in algebra, it's good manners to have exponents positive. That's what we're going for. That's kind of the golden goose. So we turn that division by 2, we just filter that out as a multiplier of 1/2. So we have 1/2 times the 4 cubed times, this is an understood times sign right here where my cursor is, between the 4 cubed and the y. So for 4 cubed and then times y to the power of this guy right here. By the law of exponents, we add this 3/5 plus 1/15th. And remember, that's 9/15 plus 1/15. That's 10/15. But remember, you can, now this time it's a little different. You couldn't reduce 8/15, but you can reduce 10/15. Now, just as before, 1/2 of 64 is 32, for the same reasons as before. But now 10/15, remember, you reduce it. 5 goes into 10 twice, 5 goes into 15 3 times, so it's 2/3 up there. So it's 32 times y to the 2/3 power. So I wanted one that had a little flavor to it, like that, so that'll work. And then here you do a similar process. The y to the negative 1, that just comes up as y to the 1 power, which is just y itself. So you do, now you can insert the steps that I skipped. I did that up here. You get 1/2 times 4 cubed times y. It's 3/5 plus 1 instead of 1/15 this time. We don't have a 1/15, a neg 1/15 on the bottom. We got a -1 on the bottom. We just add 1. And then, but now, guys, remember, the number 1 can be thought of as 5/5. So you're doing 3/5 plus 5/5. That's 8/5. Okay? And again, you'll get the 32 and times y to the 8/5. Again, the number 1 in terms of 5 is 5/5. You won't common denominator. You won't have denominators of 5. 3/5 plus 5/5 is 8/5. And again, you can insert the steps that I skipped. I can almost copy and paste this guy. I got to make that one change. Humor me while I do that. This is y to the 1 power, which is just y itself. Some authors, they won't put the 1 power. They'll just put, or they won't put y to the 1 power. They'll just put y itself. But anyway, there's that. And then you can insert that other step, this guy right here, and I make the obvious change, though. I got to go in and edit just real briefly. Again, this is not 1/15 up here anymore. It is now just +1. Or you can just say y to the 1. You can replace y to the 1 with y itself. So there's that. But I'll put the 1 power up there just to make everything obvious. So you add 3/5 and 1, and that would be 8/5. Another approach is 3/5 plus 1 is 1 3/5, and you can convert that from a mixed number to an improper fraction. But I won't bother doing that. So, but anyway, you get the idea, and that 2 is down there, and that you filter it out as a half here. But anyway, you guys get the idea on that. So, and then, well, my screen's getting all muddy here. Sorry about that. And now, if you put a -5 down here, you go through the same steps. You just have a +5 here. Now, that's kind of messy. You got to turn that 5 right here into 25/5. So you got 3/5 plus 5, which is understood to be 25/5. 3/5 plus 25/5 is 28/5. That's a little bit messy, but it's not too bad. You just got to add fractions. Or, yeah, you can do, you can turn that into 5 3/5 and go improper from mixed number to improper fraction, just whichever you prefer. And now this time, let's see. Oh, something very different is happening. I need to be careful about what I say. Let me go back up here. Notice that this problem right here, I didn't do this problem yet, did I? Oh, the last problem I did in completion was this one here from a minute ago when I had the 8/5. This is very different here. Notice that we're not just raising y to the -1 here where my cursor is. We're raising 2y, the whole brick, the whole thing, to the -1. Here we was just raising y to the -1, not the 2. Here we're doing both. So the 2 comes up. It's not the denominator is gone. It's just 1. So the 2 and the y come up. So what's happening is the step that I skipped, we can ignore the denominator since there's nothing left down there but a 1. And all we really have is, I'll try to type this real quick. I'm running out of time. But all we really have is that times 2y. And then, well, and if you got to cube you got to do the cubing first. You get 64y to the 3/5, and then times y to the, times the 2y, excuse me. So times the 2y, and now 64 times 2 is 128. So let's just go ahead, I'm kind of being silly, let's just go ahead and combine. 64 times 2 is 128. There's no use in playing ignorant here, because we know what that is. And then, now you add, by the law of exponents, you add 3/5 to this. There's a hidden 1 here. I didn't bother typing it this time around, but you can if you want to. So it's 3/5 plus 1. That's 8/5 from the same reasons as before. So you get 128y to the 8/5. And now down here, let's talk about this guy on the next video. So let's stop the video here, and we'll pick up on the next video. Thank you, guys. See you on the next video.